Derivatives with natural logarithms. Product rule, Leibniz's notation. So, as I explained in previous natural logarithm videos, when you have a function that is the natural logarithm, which is the logarithm to the base of x, you end up with, when you derive that, you end up with 1 over x. So, that's just the formula we'll be following. It's very simple once you understand it. I'll just be giving you some examples to better understand it. And this is just a rehash of the product rule following this bloke's notation. Just y is a function, and within that you have a function times another function, and the derivative is the second function multiplied by the derivative of the first function plus the first function multiplied by the derivative of the second function. So, let's start with some examples. So, let's say example 1, y equals x squared ln x. So, we have x squared multiplied by ln x. So, we have a function multiplied by another function. Let's label them. U is x squared, v can be ln of x. So, on that note, we will write the derivative, the formula for the derivative, following the product rule. V multiplied by the derivative of u plus u multiplied by the derivative of v. Okay, so we need to find the derivative of u and the derivative of v in order to complete this equation. So, the derivative of x squared is 2x, and the derivative of ln x is 1 over x, as shown before. Okay, so we fill this in. We have dy over dx, v ln x, multiplied by derivative of u, 2x, plus u x squared, multiplied by the derivative of v, 1 over x. So, if we to simplify this, we bring the 2x out the front, have 2x ln x, plus x squared multiplied by x, multiplied by 1 over x. We'll take the x out, and we'll take 1 to the power. Because technically, 1 over x equals x to the power of 1. And negative 1. I explained that in a notation video in derivatives. But basically, when you're multiplying powers, you add the power. So if you're adding a 2 and a negative 1, you end up with just the power of 1. So, you have x. Essentially, x squared over x gives you x. Okay, so, another example. Y equals e to the power of x multiplied by ln of x. Again, we have a function multiply another function. So let's label them accordingly. Label u ex and v ln. So if we write the derivative, we have v multiplied by the derivative of u over x plus u multiplied by the derivative of v on x, with respect to x. So, we need to find the derivative of u and the derivative of v. Derivative of e to the power of x is just e to the power of x. The derivative of ln x is 1 over x. So, if we fill this in, v ln x, multiplied by the derivative of u, ex, plus u, which is ex, multiplied by the derivative of v, which is 1 over x. So we can factor these out because ex is multiplied to both ln x and 1 over x. We can have ex bracket ln of x plus 1 over x. Because if we were to expand these brackets, we would get that. It's just another step to make things look a little neater, and that's how mathematicians like things. Neat, easy to understand, easy to see, simple. So that's a way of simplifying it. And we'll finish with the third example. Let's say y equals ln x plus x squared multiplied by sine x. Okay, so what we have is still a function u, which would be ln x plus x squared, and a function v, and we multiply them. That's dramatically spread out, but that's just to help you understand what's what. So, if we label u, separate the page a bit, label u as ln of x plus x squared, the v as sine x. Now we do the derivative. So the derivative is v multiplied by the derivative of u plus u multiplied by the derivative of v on x with respect to x. So again, we need to find the derivative of v, the derivative of u, and the derivative of v. Derivative of ln x plus x squared. First, the derivative of ln x is 1 over x plus the derivative of x squared is 2x. Derivative of v, which is sine x, is just cosine of x. So, to fill this in, we'd start with v, sine x, multiplied by du dx, which is 1 over x plus 2x, plus, I wonder if I can fit this in, u, which is ln of x, plus x squared, multiplied by, bring it stretched down here, multiplied by cosine of x. So if we rewrite that, dy dx, we'll have sine x multiplied by 1 over x plus 2x plus cosine of x multiplied by ln plus x squared. And that is the first derivative of this. Thanks for watching.